Hi everyone, welcome to lesson 3, histograms and stem and leaf plots. Today we're going to learn how to draw a histogram, construct a stem and leaf plot, and identify and name distributions and use them to describe graphs. In lesson 2, we discussed how to construct bar charts. Today we're going to look at a very similar graph called a histogram. Histograms are similar to bar charts, however, they are only used to represent discrete and continuous numerical data. They are not used for categorical data, unlike bar charts. If you haven't already, I would encourage you to have a look at lesson 2 before you begin this lesson. When constructing a histogram, you need to make sure you have a title that is relevant to the data you are exploring. In this case, we've just titled it a histogram. However, your title needs to be more representative of the results you're analyzing. Your x-axis and your y-axis also need to be labeled. Now, along your y-axis on a histogram, you're always going to have frequency. Difference between a histogram and a bar graph, as you can see here, is that there are no gaps between the bars. The bars are drawn right next to each other. You can also notice that we've left half of the size of the bar gap in between the vertical axis and your first bar, just like with a bar chart. You can also notice here that each of the results is positioned exactly halfway between the bars. That is very similar to a bar chart. However, if you have grouped data, sometimes we like to put the endpoints of the group on either end of the bar, as you'll see in the example that follows. I'd like you to pause the video now and jot down these points in your bound reference book before we continue. So in this example, we're looking at 300 primary school children and the distance that it takes them to get to school. So I want you to notice here that we're using grouped data. And in this instance, we in fact have to use group data because, of course, distance traveled to school is continuous. So there are many different answers that students can give. For example, one student might travel 1.5 kilometers. Another student might travel 1.6 kilometers. Yet another student might travel 1.54 kilometers. So that falls halfway between 1.5 and 1.6. And so to account for all of those possibilities, it is a lot easier to group the data like we've done here. So there are two different ways in which we can construct our histogram here because we have group data. So first way is to find a midpoint. Midpoint is exactly halfway between the endpoints of each of the groups. So exactly halfway between 0 and 2 is, of course, 1. Exactly halfway between 2 and 4 is 3, and so on. The easiest way to obtain the halfway mark, if it's not quite as obvious, is to add up the two endpoints, so 0 plus 2, and then you divide it by 2. You always divide by 2 because what you're essentially doing is adding up the endpoints and then finding the average between them. There are two values, so you divide by 2. And so, of course, 0 plus 2 is 2, divided by 2 is 1. So that's how we obtained 1. If we try that for this one here, we could have 2 plus 4, again divided by 2 because there are 2 points that I'm looking at. So 2 plus 4 is 6, divided by 2 is, of course, 3, and that's how we obtain that. Again, if it's obvious, you don't need to go through this method. However, when it becomes slightly harder, this method is a good way of finding the midpoint. And so here is the histogram of the data on the left. So you can see that we have a title that is relevant to the results that we're analyzing. We've labeled the axes like so. So here we have number of students, which is really just another way of saying frequency. And along the x-axis, we have written distance traveled because that's what these numbers along here represent. You can also see that the midpoint is exactly halfway between each end of the bar. So the bar straddles the midpoint. Okay, that is really quite important. And so that's the case for all of them. You'll also notice that all of the bars are the exact same width, and we've left half of the distance from the vertical axis to the bar. So this distance here is exactly half of the length of the full bar. So it's exactly half of the whole bar. And that's how much we needed to leave before we began our graph. Alternatively, we could use the endpoints to construct our histogram. And so it looks like this. So you can see that at the beginning of our bar, we have 0 because that is what our group begins with. The bar finishes with the 2 because that is the end of our group, and so on and so forth. Another graph that is commonly used to display numerical data is called a stem and leaf plot, and it looks like this here. So as you can see, it's almost kind of like a cross between a frequency table and a histogram, because you can see all of the answers that people give here. So we can see exactly what responses students gave or people gave that was surveyed. However, these form almost like little bars, and so they are kind of more useful than a frequency table because we can tell a bit more how our data is distributed. So it almost looks kind of like a histogram but made out of numbers. So when you draw your histogram, it's important that you have a title because the title tells us what your histogram is about. It's also vital that you include a key like this one here. So the key tells me that the first number, so the number in the stem, so this number here is in the stem, I will just use S to represent that. So when you have a 2 in the stem, and this one is after the line, so this one is in the leaf. So when you have a 5 in the leaf, what that actually means in this particular case is 25. So if we didn't have the key, then 2 with a line followed by a 5, so any piece of information given below here, what that might mean, if we didn't have the key, it might mean that it's 2.5. We wouldn't know because we wouldn't be told. And so it would be very confusing. So it could be 2.5. It could potentially even be 205 or really anything. So key is important because it tells us how to read our graph. So looking at first piece of information, we have 0 followed by 4 in the leaf. So technically what that means is the first number is 0, 4. Now we don't normally write a 0 in front of a whole number, so that would be the same as 4. So from this, we know that there was one student out of the 20 students who were interviewed who owned 4 DVDs. If we look at the second column, so here it begins with a 1 followed by a 4. So 1 followed by a 4 gives me 14. But in this row here, we also have the 6. So if you look here, it still begins with 1. So the numbers in the stem tell us what our numbers begin with. So it still begins with a 1. And then it ends, in this particular case, with a 6. So that is the next number. So far we have a student who owned 4 DVDs, another student who owned 14 DVDs, another student who owned 16 DVDs, and so on. So if you look at the whole picture, and if we wrote out all of the numbers, you can see here, so the first number is a 4, the next is a 14, the next is a 16 as we discussed before, and then it goes 2 followed by a 2, so 22, and then 2 followed by a 3, so 23, and then 25, and then 28, and then we go to the next one, which is 30, and then 34, and so because 4 is repeated because we ended up having 2 students who had 4 DVDs each. If previous explanation made sense, I'd like you to pause the video now and have a go at this example on your own. Otherwise, we're going to go through it together. Okay, so in the following example, the scores represent the distance in kilometers traveled by a group of people over a particular weekend. We need to summarize the data in a stem and leaf plot. Alright, so here's our data, so you don't have to keep flicking back and forward. Okay, so first thing we need to do is come up with a suitable title for our graph. So our data is about distances traveled during the weekend. So a title that is something along those lines is suitable. Now, we also need to come up with a key. So looking at our data points, most of them are in under 100, so they're all 2-digit numbers. Our last number is always has a value of 1. Okay, so it's in the ones column. So when we construct our graph, we need to make sure in our leaf, our answer is in the ones column. And we need to indicate with that with the key. So our key could read something like this. So 4 lines 7 equals 47. I could have chosen any other number from the list here. Now we're ready to set up our stem and leaf plot. So it's going to look a little bit like this. Now, what we need to find first is our smallest number. Now, our smallest number is 2 here. So it's often easiest to put these numbers in order, but it's not 100% required. So we have a 2. What does a 2 begin with? It doesn't really have anything in here, so we can write a 0. So when we write it in, we're going to put 0 here, followed by a 2. Now, there aren't any other single-digit numbers, so we can now go on and look at numbers that begin with 1. So we have a 12, and then we have a 12 again, and then an 18, and there aren't any other numbers that are in the value of, between 10 and 20. So 12, 12, and 18 all have in common the fact that they begin with 1. And when you write your answers in the leaf, you need to make sure you go from smallest to largest. So we're going to go 2, followed by 2, followed by an 8, and so on and so forth. I'd like you now to pause the video and have a go at completing the stem and leaf plot by yourself. Otherwise, I will show you the answers in a second. So here are the answers. I'd like you to copy this in your bound reference book if you haven't already done so by yourself. So finally in our lesson, we look at distribution of data. So distribution really talks about how spread our data is and where we can find most of our results. So histograms and stem and leaf plots are both very useful because they give us a good indication of the distribution. And there are a number of different distributions. However, the ones here are the most common ones. So data could be uniform, as you can see here. So what that means is your histogram, all of the bars on your histogram will be about the same height. They might not be perfect like they are here, but they'll be about the same height, which means that all of the columns, because this is the frequency along here, so what that means is that there are the same number of people in each section. Data can also be positively skewed. So positively skewed is when most of your data is very close to 0 or the beginning of your graph. Data can also be symmetrical. So symmetrical means that data is centered around the middle. So there is a middle value, and that's the most common value, and then it's less common as you move further away from that center. Data can also be negatively skewed, so it's quite the opposite to positively skewed. Or it can be bimodal, so that means that there are 2 peaks. So bi generally means 2, so bi means 2, and so bimodal means that it can have 2 peaks. There are, of course, lots of other different ways or names that are for distributions, but these are some of the most common ones. So for example, if these were test scores for a particular class, so for example, this could be like, down here we could have students who performed really poorly, so got between 0 and 40%, 40 to 50%, etc. So what would that mean, do you think, in each case? I'll get you to think about that for a second before we continue. Alright, so if you look at the first graph, that would mean that same number of students got, performed really poorly as they and the same number of students performed really well. So I've got the same number, so let's say 5 kids possibly, or whatever the number, performed really poorly, but 5 kids also performed really, really well. So the data is uniformly spread right across. Positively skewed, in this case, probably wouldn't be quite positive at all, because what this is suggesting is that the students in this class haven't performed quite well. So there are some students who did really well, but majority of the class didn't perform well. Symmetrical is probably what we look for most of the time when we're doing our assessment tasks, and what you want is most students to do okay, and then not many students to do poorly, but also only a few students to do extremely well. So in here, that's quite the opposite to positively skewed data. So in this case, negatively skewed really has a very positive connotation, because what it means is that most of the students did really quite well. Okay, and not many students performed very well. Now that could also mean that the test wasn't very good. So you've got to always think about, in terms of the context, what is this data suggesting? So now we'll just have a look at the examples we discussed previously. So here we have a histogram that shows the distance travelled by primary school students to get to school. So most of our data here is very close to the vertical axis. So therefore, our data is positively skewed. So what that means in this context is that students travel a relatively short distance to school, and only a small fraction of students travel really long distances. In this second example, we have a stem and leaf plot, and as you can see, 3, around 30, is where we have our peak. And as you move away from the 3, the values become less and less and less common. So what we can conclude is the data is fairly symmetrical. So most students will have approximately 30 to 40 DVDs, because that is where our peak is. And this brings us to conclusion of lesson 3. You now need to summarize the notes on previous slides and write out the worked examples in your bound reference book if you haven't already done so. You then need to have a go at lesson 3 histograms and stem and leaf plots consolidation task. You will find that in your class feed. Make sure you correct your answers using the solutions. And then you need to complete question 4 of your guides. Thank you for listening. Have a good day.